Welcome guys to today's class. In today's video, we want to discuss another important topic, that is electrolytes and Mili equivalents. Electrolytes and Mili equivalents. And so we will see what electrolytes are, see how to link it to Mili equivalents, and see important formulas and calculations we are meant to know on this topic. Let's start with electrolytes. An electrolyte is a substance that dissociates partially or completely in water or in other suitable solvent, forming ionic or electrolyte solution. Yes. Whenever a substance dissociates partially in water, we call it weak electrolytes, such as weak acids, weak bases. Example: lactic acid, ethanoic acid, ammonium hydroxide. They are weak electrolyte because they dissociate partially in water, producing unionized product of it and ionized product of it. Do not forget that unionized products that it produce, that the weak electrolytes produce, they are very important to what? Living organisms. They have high therapeutic what? Effect. Then when the what dissociates completely in water, we call it what? Strong electrolytes. Example: strong acids, strong bases. Are you getting it? That is sodium hydroxide, potassium hydroxide, H2SO4, HNO3 and others. They are strong electrolytes. In the sense that when you dissolve it in water, they will dissociate completely, producing only ionized form of it. And those ionized form of it have little or no therapeutic effect to living organisms. So physiologically, primary electrolytes include sodium, potassium, calcium, and they are called cations. And chloride, hydrogen carbonate, sulfates, phosphates, they are called anions. Are you getting? That is about physiological aspect of it. Some gases, such as HCl gas, the hydrogen chloride gas, under reduced pressure and high temperature, they are also what? Called electrolyte, or they form electrolytes, so to speak. Electrolyte solutions are produced when a salt is dissolved in a solvent and the component dissociates due to the thermodynamic interaction between solvent and solute molecules in a chemical process called solvation. We have physiological roles of electrolytes. One, they maintain acid-base balance in the body. Yes. They control body water volume. Yes. Remember, when someone just vomited or have running stomach, it lost a lot of electrolytes, and so it will get what? Weak, because what? Acid base balance is not met up, and so electrolytes helps to what? Maintain acid base balance, hence giving the person energy and good health. They help to regulate metabolism. Yes. In clinical practice, electrolyte preparations are done in the form of solution, e.g., syrups, IV infusions, and their concentrations can be expressed in miliequivalent. So miliequivalent is simply a particular or one of the ways of expressing the concentration of what? Electrolytes in solution. I take it again. Miliequivalent is one of the ways we express the concentration of what? Electrolytes in solution. And that is why we will go into miliequivalence now, so to speak. Okay, let's see how to solve these questions on miliequivalence, since we said it's one of the ways of what? Expressing concentration of electrolytes in solution. So let's see how to run these calculations on miliequivalence. Before you do this calculation on miliequivalent, you must have it in mind about this formula. You must have these formulas in mind. Number one, that miliequivalent is equal to milligram times valency all over molecular weight. Molecular weight. Yes. You can also have this formula in mind. Miliequivalent per mil Once you say milliequivalent per mil, this one will be milligram per what? Mil times valency all over molecular weight. Then, if you say milliequivalent per liter, whatever you do to this milliequivalent, you do it to milligram. Are you getting it? So this will be milligram per what? Liter times valency all over molecular weight. So these three formulas, you must have it into your fingertip. You must memorize it. You want to do well in this questions on milliequivalents. Let's see. What is the concentration in milligram per mil? Which formula? We'll be talking about this now. Of a solution containing 2 milliequivalents of KCl per mil. Wow. And they gave you MW molecular weight to be 4.5. I will say I am looking for milligram per mil. This one. That means milliequivalent per mil, which is milliequivalent per mil. I will now say 2 equals to, I'm looking for milligram per mil times, what is the valency? Valency of potassium and valency of chlorine, they are 1. We are taking 1 because valency of potassium is +1. Are you getting it? And valency of chlorine is -1. We don't use negative sign there. So we just say their valency are the same. Just take 1. If their valencies are not the same, they are not going to what? Be giving it to you here. They will use one of the what? Cation of it or one of the anion of it and ask you about that. But because the valencies are 1, that is why they say potassium chloride. But if the valency of potassium is different from valency of chlorine, they are not going to give it to you because you'll be confused of which one you are to use, so to speak. And so 1 all over what? Molecular weight of potassium chloride is 4.5. So what is the value for your what? X, which is milligram per mil. You say X, which is equal to milligram per mil. S is equal to this times this. This times 1 is S. This times this is what? So 4.5 times it. That will be 149 milligram per what? Mil. Remember, these three formulas, you must have it into your fingertips. Now, to answer question number 2, a solution contains 10 mg% potassium ion. Express this concentration in terms of milliequivalent per liter. You say, since they are asking me to get milliequivalent per liter, I will use this formula. Look at, I'm looking for this. Are you getting it? So I will be using this formula. Are you getting it? That means the milligram I am seeing here will be milligram per liter. But what does 10 milligram percent mean? It means 10 milligram in 100 mil because percent means 100. So I will now say in 1000 mil, which is equal to 1 liter. So that it will be milligram per liter. In 1000 mil will be what? 1000 times 10 divided by 100. That will be giving 100 what? Milligram. So that is 100 milligram per liter now. Are you getting it? So that means I have to get this in liter, which is 100 milligram per liter. So I will be saying the milliequivalent per liter I'm looking for is equal to 100 times. Now, because they are talking about potassium, they are specifying the cation. Valence of potassium is 1. I will say 1 all over molecular weight of potassium. Potassium is 39. Yes. Molecular weight for potassium is 39. I will say 39. So the answer will now be 100 divided by 39. And that will be giving you equals to 2.56 watts for milliequivalent per liter. Yes, and that is the answer for question number 2. Now, to answer question number 3, how many milliequivalents of KCl are represented in a 15 ml dose of 10% KCl LEC? Now, they say 15 mil dose of this. What does 10% in pharmacy, what does it mean? When we are talking about concentration, percentage concentrations, this 10%, what does it mean? It means 10 gram in what? 100 mil. 10 gram in 100 mil. This one we say in 100 because they are specified milligram already, but here they did not specify whether it is milligram or anything. Once they did not specify whether it's milligram or gram or kilogram or whatsoever, it means that you now know that it has what? Intrinsic, like invisible what? Gram in it. Whenever you see 10% in percentage calculation, 10% means 10 gram in 100 mil. If you are talking about mil aspect, but let you understand something. If you have what we say 10%, maybe weight per weight, it means 10 gram in 100 gram, because they say weight per weight. If you have 10% what? Weight per volume, it means what? 10 gram in 100 mil. Then if you have 10% what? Volume per volume, it means 10 gram in what? 10 mil in 100 mil. That is volume, that is, it will go by volume. 10 mil in 100 mil. Are you getting it? Now, but when they are talking about this one, they did not specify to us whether it is what? Volume per volume, weight per weight, weight per volume. They did not specify. But why did we say 10 gram in 100 mil? That is a question. The reason is because they say 15 mil dose. And again, we are what? Looking for Miliequivalents of it. And in Miliequivalents, we don't deal with mil per anything. We are dealing with milligram. Are you getting it? And so that is why we say that it's likely going to be 10 gram in 100 mil. So 10 gram in 100 mil is this. Are you getting it? Convert this to what? Milligram. What will it give you? 10 times 1000. That is 10,000 milligram is in what? 100 mil. That is not in milligram, in mil. But I'm looking for what? Miliequivalents only. Then I will say in 15 mils. In 15 mil, this one is in 100 mil, standard. In 15 mil, what will it give you? I will say 15 times 10,000 divided by 100. That will give you 1,500 milligram. Now, as I have given you 1,500 milligram, I will use this formula because this formula is looking for miliequivalents only. So I will say I'm looking for miliequivalents equals to, this is what? 1,500 times what? This valency, this is KCl. The valency is 1. So we take 1 all over what? Molecular weight is what? 39. Is 74.5. Because the atomic mass of potassium is 39 and for chlorine is what? 35.5. Then their standards, their standards. So this plus this will give you 74.5. So we say this divided by 74.5. 15 divided by 74.5. That will be giving 20.13, equal to 20.13 what? Miliequivalents. Remember that blood plasma contains 154 miliequivalents of cations and what? 154 miliequivalents of what? Anions. Don't forget that. And that is why we are discussing all these things, because they are used in a lot of formulations we have in infusions. Are you getting it? Syrup, suspension. We use all these units, miliequivalents, to do the formulation, so to speak. Okay. In question number 4, a solution contains 10 milligram percent. What do we mean by 10 milligram percent? It means 10 milligram in what? 100 mil, because percent means 100 of calcium ion. You see, the specified calcium ion means that valency is 2 now. Express this concentration in terms of Mili equivalent per liter. It means I'm looking for this formula, this one. Now, if I'm going by that, Mili equivalent per liter, this is 10 milligram per mil. I will say, let me convert it to what? To liter. That means 1000 mil, which is 1 liter. So 1000 mil will be what? 100 milligram. Because this times is divided by this will give you 100. This times is divided by 100 will give you 100 milligram. And so I have gotten in milligram per liter, which is this. I will now say Mili equivalent per liter will be equal to milligram per liter is 100 times valency is 1 all over. What is the what? Molecular weight of calcium, they say is 40. I write 40. 100 over 40 is what? 2.5 equals to 2.5 Mili equivalent per what? Liter. Can you see it now? So that is answer to question number 4. Going to question number 5. They say a 20 ml solution of what? Sodium chloride contains 5.13 milligram. In this case, this 5.13 is inside 20 ml. Or we say 5.13 milligram is in 20 what? Ml. What is the concentration of the solution in terms of Mili equivalent per ml? That means I'm using this formula, Mili equivalent per ml. That means I have to get it in milligram per ml, ba? Then times valency all over molecular weight, ba? Okay. Now see what you do here. You say divide here by what? Okay. In 1 ml. In 1 ml, what will it give you? Divide here by 20. Divide here by 20. Why? You are dividing this by 20 so that you get it in milligram per what? Ml. You are dividing this by 20 so that when you divide this and this, you have 1 ml. And divide this and this, you have it in milligram. So 5.13 divided by 20, you have 0. What? 2565 milligram. Milligram in 1 ml. Because for you to get it in Mili equivalent per ml, here must be milligram per what? Ml. That is the rule. So I've gotten it to be a milligram per ml. Next thing I will do is I will now say Mili equivalent per ml is equal to 0.2565 times what is the valency of this? Valency of this is what? Is sodium is 23. This one is what? 35.5. That means it will give you 58.5. 58.5. So we say sodium is 23 plus 35.5. That is 58.5. So valency of sodium is 1. Valency of chlorine is 1. I'll say 1 all over what? 58.5. So I will be having 0.2565 divided by 58.5. That will be giving me what? 0.00 what? 4 what? 4 Mili equivalent per what? Ml. Are you getting me the point? And so that is how to solve these questions on Mili equivalence.